Fraction exponents. If I said this is the square root of 16, but then I also wanted to put it to the third power. Square root of 16 we all know is 4. If I'm going to put it to the third power, do you remember that 4 to the third is 64? Does that ring a bell? Okay, now if I wanted to put this thing to the third power, I could put the third power like right there. Or weirdly, I could put the third power like this. Either one is going to make it have a to the third power. Now, that's just a little side note. Usually you'll see that they're going to put the power here. All right. Now, do you agree that 16 to the third would not be very fun to do? Like, nobody in here probably has 16 to the third memorized. So we're going to do this in the order where I've got two things to do. I got a square root and I got it to the third power. And you get to do either one first. Math is not normally so generous. Normally you have to do things in certain orders. But here, you can do the square root of 16, which is 4, and then put it to the third, and you get 64. And the answer is 64 either way. Because do you get if I do the square root of this huge number? It's going to be 64. So I can do it either way. Okay, one more thing. Did you know that there's been a little 2 right there this whole time for square root? Did you know there was even a little 2 there? I think that's one of the mistakes when teachers introduce square root is they don't tell kids that there's a little 2 there. You know, there was supposed to be a 2 the whole time. It's just that it's the most common type of root, and so when it's the most common one, you get to kind of cheat and just say square root and not have to write a little 2 there. But then the problem with that is that when we move to like cube roots, you think that this is a whole new thing, that there's a 3 there, that like, oh, that's completely different. No, there's actually been a number there the whole time. We just didn't ever write the 2 there before. Okay, so what is the cube root of 8? It's 2. Because 2 times 2 times 2 gives you 8. All right, so back to this. This is a square root, which means there's actually a little 2 there. And why does that matter? Because to write this, you would say it's 16 to the 3 halves power. Everybody write that, please. Do you get that that fraction power is upside down of what you would expect it to be? Wouldn't you think it would be 2/3? Like, you know, you read from left to right, there's a 2 here, there's 3 here, but that's not how they do it. It's upside down of what you would think. And I say something dumb about this, but I think it helps me. We'll see if it helps you. Would you agree that in most plants, the roots are on the bottom? In most plants, the roots are on the bottom. The roots don't grow up, do they? Come on. Realistically, the roots go down and the roots are on the bottom. That part is the root. I said most. I know there is weird exceptions to plants where the roots are above their head. Like you can grow plants that way. And there are certain plants that have roots above. But the roots are usually on the bottom in plants. So look, that's the root. And there it is on the bottom. Roots go on the bottom. So this is just a normal to the third power. So whenever you have like a problem that has 2 parts to it, like 9 to the negative 2, you can think of it as separate things. That's a normal 2. What's 9 squared? It's 81. 81 is in your answer. This is 81, but then you do that part of the power, and it becomes what? 1 over 81. Do you get how there was really 2 parts to that? The putting it to the 2 part, which is the 81, and the flipping it over reciprocal part. Okay, so back to this. Do you get there's 2 parts of this? There's the root part, and there's the normal power part. And I said you could weirdly do this in any order, and let me explain why. Because math always does make sense in the end. 16 is being put to the third power and then being put to the 1/2 power. And would you agree that these two are multiplied together? And therefore, you could have just as easily said it was 16 to the 1/2 to the third, because when you multiply them, you can do them in either order, you know, because 3 times 1/2 is the same as 1/2 times 3. So which would you like to do? Would you rather have to do the 16 to the third and then take the square root of it? I would rather do half power, which is the square root of 16, and then put it to the third power, because I can do that in my head. All right, do you get how when there's a fraction, there's 2 parts? Now let's see if you really got that. 27 to the 2/3 power. There's 2 parts. There's the root part, and there's the regular power part. You can do it in either order. But when there's 2 choices and one's way harder, we'll do it the easy way, which is putting 27 to the 1/3 power first, and then doing the normal 2 power later. Did you already figure out that that's 3 and then that 3 squared is 9? Raise your hand if you had 9. Awesome. Now you get fraction powers. One last twist. What if I had put a negative right there? Then the answer wouldn't have been 9. It would have been 1/9. So you can then think of it as 3 parts. The flipping part, the root part, and the normal power of 2 part. All right, let's see if you can handle that one. (125 to the negative 2/3 power). There's 3 parts. Should you square this at some point? Yes. Should you start by squaring it? No, because that'd be a pain in the butt. All right, go ahead and do it and get your answer and compare with the kid next to you. Please do compare with the kid next to you. You guys are ready to compare and mistakes. Talk to each other. Tate, did you compare? What'd you get?
1/25.
Raise your hand if you had 1/25. Awesome. Okay, good. Why? I'm going to show you for the kid that's like, I don't get this. You do the 1/3 part, that's the root part, first. Because why? Because you want to take your big number and make it smaller. And that's 5. Because 5 times 5 times 5 is 125. That part's 5. And then I would do the squaring part. 5 squared is 25. And then I would do the -1 part. That's like a -1. Well, you could think of it as -1 times that. And then altogether, I've got my negative 2/3 power. They're just broken up into parts. Final answer, 1/125. All right. 64 to the what power do you think I'm going to do? One-fourth would be a little too hard because the 4th root of 64 is not easy.
1/3.
Okay, and 1/3 would be a little too easy because, 2/3. And then what could we do to make it one step harder?
-3.
That's it. Everybody try doing 64 to the negative 2/3 power. The root part, the regular power part, and the flip part. Actually, in any order you want, but there is an easy way. Do it the easy way. Let's see what you got compared to the kid next to you. Okay, you should have done the 64 to the 1/3 part first, and then the squaring part, in my opinion, and then the -1 part last. So this part would be 4 squared is 16, and then that -1 part puts it 1/16. Who had 1/16? Awesome. Now what if I do the same thing except with letters? N is to the P, and then there's this square root sign with an R right there. What the heck does that mean? Please rewrite that with a fraction power. Hint, N to a fraction power. And this is that moment where if you remembered that dumb little thing I said, the root goes on the bottom, and that's the root part. The root goes there, and the other power would go there. Raise your hand if you had that one right. Okay, cool. What if I put 1 over all that? What power would it be now? Negative P over R. Okay, let's do another one like that. This one, you're not going to know the answer, but you should be able to write it as a fraction power. 1 over the square root of 47 to the 5th. Just write this as something to a fraction power. Ethan, if I start with 47, can you do the rest? Negative 5 over 2. And did the root go on the bottom? Is that the root?
Yeah.
So did the root go on the bottom? Yep, there you go. Raise your hand if you had that one right. Okay, good. All right, I feel like you're understanding it. So what more could there be? Well, let's go ahead and jump into the notes. We'll go through them really quick. Just a review of yesterday. You want to make the bases the same. Is 3 the same as 81? No. Could you make the 3 be the base for the 81? Yeah, 3 to the what? 3 to the 4th. And why is this wrong right here? Yeah, that x was there. It's still got to be there. And so I'm going to put this in parentheses and put the x there. And now it's still kind of missing something. Brody, what's it missing? I need the powers to be the same. There's no power.
1.
Yeah, there's a 1 right there. So now you can say 4x has to equal 1. So x has to equal 1/4. Raise your hand if you had that right. Good. That's just a review from yesterday. Let's do one more weird one like that. These are hard on the test. So let's say I said 4 to the x minus 2 has to be equal to, I'm not going to say 16 because that would have been too easy. I'm going to say 8. Because then kids are going to be like, how do I make 8 into 4 to a power? And then you can't. So can you figure it out? I'll pause for a second while you try to figure out a base that could work. Tate, what'd you use for a base in both of them?
2.
Good. So I'm going to do something that a lot of kids do wrong right here. 2 to the x minus 2, 2 to the 3rd. The problem is you just changed 4 to 2. Is 4 the same as 2? No. So if you said 2 squared is 4, now it's right. Next mistake, they say a good teacher is supposed to know where kids are likely to make the mistake and really show them. 2x minus 2 is equal to 3. Wrong. Because a lot of kids forget to distribute this. So it's 2x minus 4. And I guarantee you somebody in the room made that mistake. Although I did pound on it yesterday, so hopefully you didn't make that mistake. All right, now I have to add 4 to both sides. And I get 2x equals 7. Oops. And then x equals 7/2. Raise your hand if you had x equals 7 over 2. Okay, good. Okay, on the next page. Do you just have these memorized yet? 64 to the 1/3, you should be able to go, oh yeah, that's this. 49 to the 1/2, oh, that's this. Because you can't do a normal fraction exponent, then how on earth are you going to do it when it's like to the 2/3 or to the negative 2/3? All right. 64 to the 1/3, this feels like a time where I should roll the dice. Get some answers from the crowd. Row 2, last person, Anders, that is you. What is the first one? 4. How about the second one?
7.
And the last one?
2.
4, 7, and 2. That should have been easy. All right, on to the next one. 8 to the 2/3. Again, you can do it in either order. Do you want to take 8 and square it, which is 64, and then take the 3rd root? That actually works. It's not that bad. Or you could take 8 to the 1/3 power, which is like making it smaller first. That's generally advised. And then make it bigger. Either way, what do you get for that first one? 64. 4? Just 4? Wait a minute. Oh, you're right. It is 4. It is 4. Raise your hand if you had 4. Okay, good. All right. Do these next couple. Should be able to do them in your head quick from the practice that we did before. Row 2, person... No, wait. Row 1, person 2. Tate, that's you.
Second one, yeah, 8.
Raise your hand if you had 8. All right, good. Next one. Row 1, person 3, Afton. Are you doing 4, 1/2 is 2, and then you just stuck on 2 to the 5th? I would understand that. Anybody know for sure what 2 to the 5th is?
32.
Raise your hand if you had 32. Good. I know that's a hard one to do, but you could do it 2 times 2 times 2 times 2 times 2, and it's just, eventually you get to 32. All right, this next one, 32 to the 1/5, that kind of is like a lot like this, isn't it? Because then it goes back to 2, and then you put it to the 4th. 2 to the 4th is 16. And then this one is the 3rd root of 27, which is 3, and then you square it is 9. You see how these get to be really quick after a while? What if all of them had been negative powers? Put a 1 over it. That's it. So if this had been negative 2/3 power, then you'd say 1 over 4 is your final answer. Okay, enough on that. So how do we undo a fraction power in an equation? You put it to the inverse of that, or the reciprocal of that. So you get how the 1/3 is going to multiply by the 3 then, and then it's going to turn into x to the 1, which is the same as x, right? And then 3 to the 3rd is 3 times 3 is 9 times 3 is 27. Here, don't start with putting everything to the 4th. We follow PEMDAS. But in solving equations, we add or subtract first. So what do we add or subtract first? Minus 8. Then it's x to the 1/4 is equal to 2. Is there any multiply or divide we could do that would help? No. So then we're done with multiply and divide and add and subtract. The only thing that's left is exponents. Is there anything exponent we could do? Yes, we should put it to the 4th. And that is really just 2 to the 4th then, which is really just 16. You know how you make sure that an answer is right? You go stick it in here. Watch what happens. 16 to the 1/4 is 2 plus 8, 10. It worked. See? Right. Holy crap, they get this hard? Yes, they do. You just got to remember to do them in the right order. PEMDAS. Except in reverse. So you start with any add or subtract you could do. What could I do to make this better by adding or subtracting? Adding 7. 3x minus 3 to the power of 3 over 2 is equal to 27. Now, I know that some kids are going to think we can add 3 to both sides. You cannot. That 3 is stuck on the inside there until we deal with the exponent next. We have to get rid of that before we can free up the 3x minus 3 on the inside. Well, how does that fit your rules, server? Then the next thing we have to do is jump to the exponent and get that done. I know it feels like we skipped over the multiply and divide part, but these guys, if you wanted to put all of that to that power and kind of distribute it out, you could. It'd be a nightmare. So instead, we're going to get rid of that exponent to free it up. And then we're going to go back and follow the rules again. It's a little bit like if you had parentheses inside parentheses. You have to start with this, and once you're done, you reevaluate everything else. So if x was equal to like 10, you would start in here, and then you'd reevaluate, what do I have now? Oh, I guess I can move to something else. So it's like I'm getting rid of this power, and then I'll reevaluate, and then I'll go back and like say, what's next now? Okay, so I'm going to put this to the 3 over 2 power, That's why we needed you to know how to do 27 to the 3/2. And that one didn't work real nice because I just did it upside down. It should be, the 3/2 is right here. So this should have been a 2/3. 2/3. And I knew because I was like, square root of 27? That can't be right. So that's how I caught myself. So that's the root. Third root of 27, that works. And then I square it. I think it was 9, was it? Okay. And then you just have to add 3 to both sides. 3x is equal to 12. X equals 4. All right. I want to, before this happens, I want to just remind you of something. Because otherwise, literally everybody is going to screw this up when we hit this problem. Go back to basics. If you had x squared is 16, I know the answer is 4. But what's the common screw up here? Plus and minus. Why does that happen? Well, let me show you. If I square root both sides, I got to remember I did a square root of a variable, which is the absolute value of it. Some kids have been taught that the square root of 16 is 2 things. It is not. The square root of 16 is just 4. But some kids were never taught that when you square root a variable, you get the absolute value. I really pounded on that hard in first semester. So most of you that had me for first semester already know that this is an absolute value. So why does that matter? Because do you get, when I put the square root in on both sides, it was like this. I could have been putting it to a 1/2 power. Because that's the same thing as the square root on both sides, isn't it? And if that's really the same as square rooting both sides, unless you've got a screwed up head because of some teacher who told you this is positive and negative 4, it's not. It's just 4. Then you'll be able to remember, oh, the reason I get 2 answers is because that's an absolute value of. And again, I'm aware that some of you were never taught that. Now you got to learn it because it's true. Because otherwise, kids think that the square root has 2 square roots, and there isn't. If you square root 100, there is not 2 answers. There's only 1. You can ask ChatGPT. You can type it into Desmos. You can do it in a ton of different ways. You can just do it on your regular calculator. It doesn't give you 2 answers. There's only 1. The reason there's 2 answers for this question is because of this. Okay, so I did all of that because in a second, some of you are going to forget that. And you're only going to get 1 answer when you're supposed to get 2. Final answer is, split this into 2 things. X equals 4 and x equals negative 4. There is 2 answers because of the absolute value. Because when you put it to a fraction power, and just to clarify, only when it's even. Only when it's even. Why? Because you can do the cube root of negative 8. It's fine. You just get 1 answer, negative 2. So cube roots, roots that are like this, when you do that to something, you don't have to worry about losing an answer because there is only 1 answer to that. So the only time it matters is when you put it to a fraction power where the number on the bottom is an even root. Because odd roots don't have problems with negatives. You just get 1 answer. So if you ever find yourself doing this to both sides of an equation, you just square rooted both sides of the equation, and there'll be 2 answers. Even with all that reminder, it's going to happen. Maybe not yet, but it's going to happen later this hour. Okay, everybody try this one. There's a first step that's not that hard. Lucy, what do you say we should do first? Add 5.
Plus 5.
Okay. 2x minus 4 to the 1/2 is equal to 7. Lucy, what do you think we should do next?
Find the base.
So I'm going to put it to a power that gets rid of this little 2 right here. What power would do that?
Power of 2,
Yep.
40,
Just 2.
40.
Just 2. Just to the power of 2. Now, by squaring both sides, do you have to do that absolute value thing? No, if it's square rooting both sides. Squaring both sides, no big deal. So squaring this gives you 49, just like you'd expect. And this do cancel each other out, and you have 2x minus 4. And then it's not, you know, like, Lucy, why don't you just finish it up? What's the next step?
Plus 4. And then 2 over 53.
There we go. Any questions? Now you might be like, didn't you just say a second ago that you're going to have 2 answers? Not on this one. Why? Did you ever put it to a fraction power on both sides? No. We squared this one. That does not cause 2 answers. Square roots on both sides cause that. All right. These 2 should go easy. Mateo, question? Give me 1 minute and I'll be done with the lesson, and then you'll be able to. We're going to put this to the 3 over 2. 3 over 2. That's the square root of 4, which is 2. 2 to the third is 8. X equals 8. Nobody even just noticed. Yes?
Is it plus or minus 8?
It is plus and minus 8. Didn't I say that everybody'd miss it? And you almost did. Why? You just put it to a fraction. That's a square root. You just square rooted both sides. It's so easy to forget. There's 2 answers. X equals 8 and x equals negative 8. Let me prove it to you. If you go back up and put in negative 8 right here, you could get an answer that would work just as well, because you're going to get negative 2, but you're going to square it. It's going to come out the same as if you put in regular 8. Do you get what I mean? If you had a negative 8 here and you put it to the 2/3 power, you'll get the same exact thing as if you had a regular 8 there and you put it to the 2/3 power, because you'll get 2 or negative 2, and then when you square it, you'll get the same exact thing. So you see how easy it would have been to forget one of those answers? Why did it happen? Because we put it to an even root. Okay, let's see if it happens again. Olivia, how do I start this one?
Plus 8.
Yep. And now I have x to the 2/3 equals 9. If I solve it from there, Daniela, we're putting it to the power of? Okay. Daniela, do you know? Yes. But how do I fix to the power of 2 over 3? By putting it to the power of 3 over 2. And that makes this turn into 1, and then this is just x, and then this is, I'm already wrong. Did you catch it? We put it to an even root again. Absolute value of x. Square root of 9 is 3. 3 to the third is 27, but you need 2 answers. Why do you need 2 answers? Because both would work here. In the end, it's because if I put in negative 27, once I square my answer, it'll be the same as if I put in regular 27. See? Okay. 2 answers. So easy to forget. It's going to happen on the test. You know kids are going to forget that. So try to remember, if you ever put something to a fraction power on both sides, you know, like find yourself doing this on both sides. Wait. find yourself doing that on both sides, then you have just square rooted both sides, and you need absolute value on your answer to give you 2 answers. Okay, I think that's good enough. From here, we've practiced all the other stuff, so I'd like to get into your homework. So everybody open up the homework and read me problem number 1. Carter, it's going to be you when you get there.
The first one?
Yep.
4 to 5 over 2.
That's it?
Yeah.
Okay, good. So then I'd do the square root first if I were you. So what is it?
Square root.
Yep, square root of...
16.
So wait. Square root of 4,
Yeah.
which is?
16, right?
Square root of 4? No, square root.
Oh, square root.
It's like 4 to the 1/2 power. And then we'll do the 5th later.
It'll be 2.
2, and then to the 5th.
I don't know what it is. With it.
All right, 2 to the 5th is 32. You should memorize that one, though, because there's no calculators in this test. So 2 to the 5th, you got another one. Okay, now, did we just have a square root? Yeah, but that's not the same as doing a power on both sides of an equation. So there is not 2 answers to this. There's only 1. That's the difference between just saying like 4 squared, that's 16. That doesn't have 2 answers. Versus if I said x squared is 4, that would have 2 answers. Because I'd have to put it to a power on both sides. If I put it to a power on both sides of an equation, that's when I get 2 answers. Not just because you did it once. It's because you do it to a variable. When you do it to a variable, watch out. All right. So number 1 was just 32. Now, I want to look at the worksheet, so I'm going to pause for a second, see which ones to skip. I guess I just realized that my video was paused there, so we have figured out that we're going to skip these. Skip 14, 16, 18, and 20 on the worksheet. And I know that leaves you with number 22. It is a hard one, but you should practice the hard ones. And I want to do one more before we wrap up the video. Number 2, would you please read me number 2? I'm sure you're already done with it, but...
25 over 9 to the negative 1/2 power.
All right. I know that that means square root. So I'm going to square root both of them. 5 over 3. Am I done? No, I put it to the 1 power. Well, that's still 5 over 3. But then you do the negative. And did you say 3/5? Excellent. The final answer after you apply that negative is you flip it over and you get 3/5. Okay, if you need help, please walk up and ask. I'd happily help you.